பொம்பளை பிள்ளைங்க தான் மோஸ்ட்லி. அங்கே சஞ்சய் ஒருத்தர் இருக்காரு, அவர் ஒரு ஆள் தான் மேல். எல்லோரும் ஆர்கானிக் கெமிஸ்ட்ரியில் சின்சியராக பிஹெச்டி பண்ணுறாங்க. ரைட். ஸோ இட்ஸ் கைண்ட் ஆஃப் அ மோட்டிவேஷன் தான். நாங்களாம் யாரும் பெரிய பணக்கார ஃபேமிலி எல்லாம் அப்படியே அம்பானி ஃபேமிலிலாம் கிடையாது, எல்லாம் மிடில் கிளாஸ் ஃபேமிலி தான். ரைட். ஸோ வி கேன் டூ இஃப் யூ ஷோ சம் இன்ட்ரெஸ்ட். அவ்வளோதான். எந்த சப்ஜெக்டாக இருந்தாலும் ஒன்றும் பிரச்சனை இல்லை கெமிஸ்ட்ரியில். இந்த இன்ட்ரெஸ்ட்டு நான் பிஹெச்டி பண்ணணும்னு நினச்சிங்கன்னா இந்த எண்ட் ஆஃப் த ஸ்லைட்ஸில் நான் ஒரு 2 ஸ்லைட் நான் உங்களுக்கு ஒரு சர்ப்ரைஸ் வச்சுருக்கேன். ரைட். அதுன்னு யாரும் தூங்காதீங்க. நான் கோர் ஆர்கானிக் கெமிஸ்ட்ரி தான் ஐம் கோயிங் டு டாக். சிந்தசிஸ். பிகாஸ் கெமிஸ்ட்ரி மீன்ஸ் சிந்தசிஸ், ரைட் ஆர் நாட்? Mostly, most of the people likes organic. How many of you do not like organic chemistry? எத்தனை பேருக்கு ஆர்கானிக் கெமிஸ்ட்ரி பிடிக்காது இதில்? வெரி குட் ரா, சூப்பர் ஆட்டிடியூட், ரைட், வெரி குட். ஸோ அப்போ எல்லாருக்கும் உங்களுக்கு பிடிக்கும், ரைட்டா? ஓகே ஓகே ஓகே, லிசன். See, if you cooperate with me, I will finish 40 minutes. Otherwise, I will take up to 1:30. ரைட். எது பார்த்துக்கலாம், நீங்களே டிசைட் பண்ணிங்க. half an hour வடிவேல் சொல்கிறாருல்ல ஒரு மூவியில், அது மாதிரி முடிச்சுட்டு ஓடிட்டே இருப்பேன் நான். ரைட். ஸோ யூ ஜஸ்ட் ஃபாலோ மீ. ஏதாவது ஒரு கெமிஸ்ட்ரி சின்னதாக ஒரு ரியாக்ஷன் நீங்கள் கற்றுக்க முடிஞ்சால் கற்றுக்குங்க, லேர்ன் பண்ணிங்க. எல்லாமே நியூ கெமிஸ்ட்ரி, நீங்கள் பார்த்தே எடுக்க மாட்டீங்க, ரைட்டாக? நீங்கள் கேட்டு இருப்பீங்க. பட்டு இது புது நியூ கெமிஸ்ட்ரி என்ன பண்ணியிருக்கோம். ஸோ மோஸ்ட் ஆஃப் த ஒர்க் ஆர் டன் பை மை ஸ்டூடெண்ட்ஸ், ரைட்? அதை தான் நான் ப்ரெசென்ட் பண்ண போகிறேன். ஓகேவா? ரைட். எதுப்பா எது? Okay, ready appa? So the title of the work today, what I am going to talk, is ring closing metathesis. Ring closing metathesis. What is this? Right? So that's what we are going to discuss here. It's a method, a plausible method for the synthesis of nitrogen oxygen heterocyclic compound. What are heterocyclic compound? BSc level la neenga padichirupinga. Compound other than cyclic ring la, other than carbon, hydrogen, any other atom like nitrogen or oxygen or sulfur are there, they are called as heterocyclic compound, right? Okay. So it occupies various part of the chemistry also. Even pharmaceutical, paint industry, polymer industry, everywhere people can see that heterocyclic compounds. Right. What is the plan of the today's topic? So I'm going to talk about a few works, what we have performed in the laboratory, what we have published in the research journal, right? So the first part of the work is a ring closing metathesis, right? Synthesis of pyrroles, pyridine, azabine. What is a pyrrole? Pyridine, azabine, I will show you later, right? So via N1 diallylation or homoallylation followed by ring closing metathesis. Here after ring closing metathesis I may say as RCM, right? Okay, RCM, right. The second part is synthesis of diazoninone. It is a 9-member ring. How do you synthesis? How do you form a 9-member ring, right? So those things I'm going to discuss later. That 3-spiropentene and 3-spiroheptene of 7-aza-indolone. It is also an heterocyclic compound. How we have going to modify those 7-aza-indolone into the required compound. Then part B is another methodology. This is a part of the ring closing metathesis only. Ring closing E9 metathesis. Here we are going to discuss about that synthesis of spirodihydrofuran and pyrene derivatives. Okay. So what is olefin metathesis? What is ring closing metathesis? So because you are all MSc, PhD, MSc and BSc students, you should know this new chemistry, right? So very old chemistry. Most of the scientists have done a lot of marvelous work in this area. Right? For you, it might be you are hearing first time or not, I do not know. So anyhow, so two olefins. Look at that. Olefins means ethylene, CH2, right? Ethylene, right? Propylene. So two olefins. Both are in the terminal. Terminal means this is a kind of alkyne chain, right? It's two olefins are there here. These two olefins close together form a ring compound. It is called ring closing metathesis. Right? அது காதில் கம்மல் போடுறீங்களா முதல்ல எடுத்துட்டு தானே போடுறீங்க அதுக்கப்புறம் அது எப்படி க்ளோஸ் பண்ணுறீங்க ரைட் அதுதாங்க பண்ணுறோம் வேறு எதுவுமே கிடையாது ஸோ இட் இஸ் கெமிஸ்ட்ரி ரைட் தட் இஸ் ப்ராக்டிகலி வி ஆர் டூயிங் ரைட் ரிங்கு கம்மல்னா ரிங்கு அதுக்காக இந்த சின்னதாக இந்த டப்ஸ்லாம் சொல்லக்கூடாது என்கிட்ட ரைட் அண்ட் தென் ring opening metathesis. Once you have closed, you should know how to cut that molecule. So that is called ring opening metathesis. And then this is acyclic diene metathesis, a kind of a polymerization, and then cross metathesis. These are all the various methodology available in the organic synthesis to synthesize the compound. Right. So, what is the catalyst we are going to use here? Professor Robert Graves, right? He was awarded a Nobel Prize to, he has introduced this catalyst, right? So ruthenium catalyst. He has been awarded Nobel Prize. That's what I want to say there. So we have followed, we have taken this chemical to synthesize our compound. So fortunately, I want to mention here, so I have met Robert Graves in VIT, Vellore. He was sitting before the Corona period, 2020, exactly in the January. Right, at the time we have started a couple of work, were published at the time. We met Professor Graves. We are very fortunate to sat with him to discuss something about this chemistry. So, he is no more right now. He is passed away, right? So, this is the Graves catalyst. So, we are using to cyclize this molecule. So imagine, whenever I'm saying that a ring, you imagine, right? Ring is open, you are going to close it. That's it, right? So in the literature, there are, see, before starting any work, we have to see the literature. What is available? What is synthesized? What type of catalyst they have used? How many minutes they have taken? Everything we have to refer that. So using literature, so we found that this the 2,5-dihydropyrols are reported. So why not? We can try also such kind of molecules. So we have also the 9-membered ring. See that it's a 9-membered lactam. From you calculate 1, 2, 3, 4, 5. This lactam, see, 2 nitrogens are there. Right, diazo molecule, right? Understand? So why not? These type of molecules, so very few reports are available in the literature. So we have started this work. One of my students is now working in an industry, right? So what is the use of studying chemistry, sir? Shall I go to teaching job or industry job? Industry job is also there. So he has been paid a very high salary right now. You cannot imagine. I do not disclose his salary also, right? So there are a lot of opportunities are there while studying chemistry, especially organic chemistry. These areas are very, very, well, very, sir, you can get this job very easily right now, even pharmaceuticals, right? Okay, having seen that, we have synthesized these type of pyrols, pyridines, dihydropyridines, dipyrols, and then azepines. Also the 9-membered ring, diazoninone derivative also synthesized. Taking from the starting material, it is nothing but orthoamino benzamide, anthranilide. Very simple. It is available in lab. My student was having this compound. He has ordered. It's very cheap chemical. Right? In his desk, it was there. So I have sent him to do this reaction. At that time, I did not have any facility in my laboratory. In CLR, I sent CLR Chennai. So my senior, Dr. Shanmugam sir, was taking care of him, that guy. They have seen that bottle, right? So from this chemical, shall we do something? See, the research work, we cannot go and purchase the chemical and then do the work. Whatever available chemicals available on your table, you take it and then do it. So it is easy, right? So instead of going and paying, what is available with that limited facility, we can do the research. That's what I'm asking my students to take care of that. Don't go any new chemicals, whatever available. With that you can do something. So that may work always. So we have started with that benzamide, orthoamino-benzamide. Initially, look at that amino group is there, right? Here, the allyl bromide, we want to alkylate this amino group, both the amino group. Right? This is a molecule we expected to synthesize. But actually, chemistry may not work what we have expected, right? Understand? So the allylation gone only with this NH2 only. Right? Aryl amine NH2, not with the amide. So there are few literature reports also there, but it is very costly. You have to use a nickel catalyst, a lot of time, you have to spend energy, a lot of money we need. Right? But we had a very limited facility, I told you. With that only we have tried to get that one. So we have studied that what is the condition to be followed, optimization. Whenever you do any work, you have to do optimization. You ask your mother, she is preparing any new food material, right? One day one taste, the other day other taste. But if you go to any hotel like Sharana Bhavan, the same sambar is same taste. They do not have any same taste because they are processed everything. They have fixed that methodology, how to prepare the sambar. Same thing. Chemistry also like that only. So before doing any reaction, you have to optimize the condition. So we have optimized. So it worked well using potassium carbonate as a base in acetonitrile at a microwave condition. Right, within 4 minutes, we have got 92% of yield. All the structures of the molecules, everything confirmed by all spectroscopic studies. Organic chemistry, NMR, IR, UV, everything you have to do. Right. So whatever the compounds I am showing here, everything are characterized by spectroscopy technique. NMR also, 13C NMR, depth NMR, all are there. So these are the various alkylated products we have synthesized, taking a lot of starting materials available, right? So finally, the structure of the product, see, wherever you see in NMR or C13 NMR or mass you show, right? You have 50-50 possibility. Always a crystal structure will tell you the story. This is your compound. So whenever you see the crystal in the laboratory, see, we used to get happiness like anything. That's a newborn baby only like that. My compound, my crystal, right? Its structure is this. You have to confirm it. So we have confirmed by X-ray diffraction studies. So then once we have that, the terminal alkenes. See, look at that. This is one alkene, here one alkene. We have used the Krebs catalyst, first generation catalyst, initially, and tried to cyclize it. Within a few minutes, we can able to get that product. Right? Initially, we have expected to do 9-member ring, but we have ended with the 2,5-dihydro derivative, so no problem. So we can derivatize this. We can stabilize the chemistry. So like that, we have synthesized various derivatives of 2,5-dihydropyridines and pherols, right? And then tetrahydropherols, and then azabines. All the compounds are synthesized in our lab only. So every compound you have to characterize. So you can understand that very tough, right? All the compound you have to characterize. It will take time. That's what Sir said, PhD, right? It's not a time bound. You have to spend a lot of time in the laboratory. You have to work hard. You have to make that everything confirmed, right? So time-taking process, but dedication, passion, Professor Natarajan was saying in the morning, that also should be there. Then only chemistry you can shine. If you go to the industry also, they will ask you to do the same thing only, right? Maybe they are paying money, some money, 25,000, 30,000 per month, right? Like a donkey job, you have to do that, right? Understand? But if you have a PhD with you, you may be right royally, you can work as a manager, right? Let me come to that chapter later. So like that, so we want to exploit this chemistry into the various derivatives. I'm just running short of time, so I'm going a little faster. So we have synthesized that dihydropyrols, and then the structure is again confirmed by single crystal X-ray diffraction studies. So later, once we have done that, the pherols and the pyridines, what is our aim? So we have reworked, and then so we want to alkylate this NH2 using same allyl bromide, right? So there also we have done that with the optimized condition, we have got that, and also we have prepared various derivatives, and then we want to do the ring closing metathesis here. So there also we have ended with that corresponding dihydropyrols, but we are not end up with the 9-member ring. So let me go to the next stage. So we thought that the NH, because the alkylation, you see that in the previous slide, the alkylation, only monoalkylation happened. So we want to replace this hydrogen also. So we have replaced that with the allyl bromide again. So tetra allyl derivative we have done, right? So also we tried the same ring closing metathesis strategy here. So we have end up with the bis dipyrrole derivative aminamide only. So also, once we have that any molecule, you have to show to the people that this molecule should be useful for biology or photophysical studies, physical chemistry or something. We have to show that. Then there is no use. What is the use of synthesizing this compound? Yes or not? So we have to do some studies. So for those reasons, so we have converted that product, whatever the product we had, right? We have converted into that derivatives. That is called synthetic transformation, right? So the derivatives, we have taken this iodo compound, so we have made this biphenyl. Once this biphenyl structure is there, it may show beautiful photophysical properties. Studies, you can have that, right? It's show fluorescence, and you can study that, what is that lifetime, everything you can study. So the application move on to the other side. So that we have made, and we have proved that this compound should be converted into that corresponding synthetic transformed product. And finally, we want to end up with our 9. Finally means I'm not closing my lecture. This work, right? So what we have done that, so we need to substitute all the hydrogens in the amide, in the amino group. So what we have done, initially we have done on a Chan-Ewan-Lam's reaction. So we have converted into that N-phenyl derivative, right? And then allylation I have done. So we have allylated. So we allylated, and then we have this system completely substituted, because if both are similar, so we may end up with the pyrrole only. If we have, other than allyl group, one phenyl group is there, so we can try whether the reaction is happening or not. It happened. Fortunately, we got that 9-membered ring. No one has done this type of compound in the world. Very happy, right? But how do you prove that you got it? So that was the headache for us. We did not get the crystal. Only by NMR we can say that NMR, mass, but nobody can believe that if you are not showing any crystal in organic chemistry. You have to do that, prove that structure, you got the 9-membered ring. It is not easy to get the 9-membered ring. So what we have changed the strategy again. So what we have taken that, the isotoic acid is a starting material. These are all the new compounds, you may not know that. If you open it, right, so this amide portion, see that this amide portion, that NH is replaced with the N-phenyl, right, understand? Also this is ready now. Here one Chan-Ewan-Lam reaction, if you do that, here also N-phenyl. Only both the hydrogens are available to replace it with the allyl bromide. So we have substituted with the allyl bromide. Alkylation I have done in the basic condition. Once this is ready, shall we try? Because we have done only to get that crystal, right? So there we have achieved that 9-member ring is formed. Also we have derivatized many compounds we can able to synthesize, and then we had an excellent X-ray crystal study, right? Report. See that it's a 9-member ring. It is, maybe you have to imagine, right? You have to see that, right? So 9-member ring is formed, and then the phenyl group is here. So it is proved, and then it is got accepted in the publication. So organic chemistry is very difficult only, what I feel. But if you do properly, say this is a 1-year work of my PhD student, right? He has done a lot of efforts, he has put his effort and then learned. So why I am saying that MSc itself, if you have this kind of attitude, habit, then it's really good for you. See, not all the people will go to PhD or industrial job. You may have your own business and you can do that, whatever government job or anything. But those who wants to come to the research, this is the basic. You have to follow this. If you are not following, the sincerity is not there, it's very difficult. Understand? Right. Next, coming to the synthesis of 3-spiropentene and heptene of 7-azo-indolone by ring closing metathesis. This work, you just see that quantum of the work, a girl has done this work. So a lot of work, right? She has spent a lot of time in the laboratory, right? So always, I never stay up to 10 o'clock, but my students have to stay. They may stay themselves. Morning, 8 o'clock, they used to come to the lab, they used to walk, right? They may do their job because they know that what is their responsibility. That much of hard work. See, like you only, my girl, they came from very remote colleges only, right? From Utangarai, from Auxilium College only in Vellore, right? They are all came from such kind of colleges only, not from big universities, big institutions. And they have been trained properly. They have been showed that. Right? We have tried to cyclize this with a gloves catalyst. We have optimized the conditions. The gloves 2 is a second generation catalyst. right? This one only we have used. First generation also giving the product, but the good results are not given. So we have tried with the GRUBS2 catalyst. Most of the reactions we have tried with the GRUBS2 catalyst only. All right. So we have got that 84% of yield of this product. Once this is made, then all the compounds we have to convert it, right? So look at that. The funny things are also there here. So we have tried to cyclize this mechanism. I'll show you how this is happening, cyclization, right, later. So once you get that 5-member ring fused with this third position, spiro junction. This is called a spiro junction. Those who are MSc students, you should listen carefully. This is a spiro junction. This type of compound, this stereochemistry is very important for many biological activities. So that is the reason we have prepared this. So we have prepared all the big ring structures. See that, look at that 18-member ring. This is very important. This is not easy to prepare. It is accidental research. When we are doing something, we got what is expected that product. Other than that, something we got it, right? So we have suspected that this should be a bis spiro product, but based on NMR and IR, we cannot confirm it. Only one way is you have to get the crystal structure. So again, crystallization is challenging. My student, actually, she has recorded the NMR, right? And then NMR tube, I think you might have know about that NMR tube thing, right? Otherwise, next time I'll show you, right? That NMR tube, she has kept that sample as such, and she has gone for the weekend. And after she's coming back, she saw that one sakara mari or crystal, kalle. வெளியே கல்கண்டு வச்சிருந்தீங்களா அதே தான் ரைட்டா ஸோ சின்னதாக ஒரு கல் அது ஏன்னா ஜம்பிங் லைக் எனி திங் ஓகே ஃபைன் வில் கோ ஃபார் எக்ஸ்ரே அனாலிசிஸ் ரைட் வி ஹவ் காட் அன் எக்ஸலண்ட் கிறிஸ்டல் லேட்டர் ஐ ஷோ யூ அண்ட் ஆல்சோ only in the case of indole, see I have shown that in the case of azaindole here n was there, here only indolone. So we have seen that the cross metathesis product also. So these are all serendipity result, unexpected. Something you are doing, something may happen. என்ன சொல்லுவாங்க வீட்டில் சொல்லுவாங்க இல்லையா பிள்ளையார் பிடிக்க குரங்கா போச்சுன்னுவாங்க ரைட்டா எஸ் ஆர் நாட் அதனால நாங்கள் என்ன பண்ணோம் குரங்கு வரும்னு எதிர்பார்த்தா ஆனால் பிள்ளையாரே வந்துட்டார் ரைட் ஓகே ஸோ தட் வே சம்டைம் ஆக்சிடென்டல் ரிசல்ட்ஸ் தான் உனக்கு நோபல் ப்ரைஸே கொடுக்கும் நிறைய பேர் எங்கெல்லாம் கொடுக்கல பட் லேட்டர் ரைட் மோஸ்ட் ஆஃப் த சி பெனிசிலின் தம்பி லாஸ்ட் மேட்ச்சு பென்சிலின் கேள்விப்பட்டிருக்கிறப்பா யார் கண்டுபிடிச்சது அவர் சார் சொன்னார்ல காலையில் ஒரு டை வந்து ஆக்சிடென்டலாக லேபில் பண்ணோன்னு இந்த மாதிரி தான் லேபில் வந்து எனி ஆக்சிடென்டல் ரிசல்ட்ஸ் வந்து டெஃபினெட்லி இட் வில் கிவ் யூ சக்ஸஸ். சேம் திங் ஹேப்பன்ட் ஹியர் த ஆக்சிடென்டல் டிஸ்கவரி we have got this product. Okay, see, look at the structure now. You may be happy seeing that 18-member ring. Look at that. The 18-member ring core is here. This is one indolone structure. This is one indolone structure. The same structure is given here. So beautiful. How beautiful. If you have O or nitrogen in between, those compounds are very, very important in biology. Right? The 18 crown 6 ether you might have studied or not in your BSc level. Right? So crown ethers, they are very much, they have that applications in biology. So we are trying to make that also. It will be my future plan. So all the structures were proven by crystal structure. Then we have tried to see that how this is happening mechanistically. So we have done some catalyst concentration studies also. Taking one compound in this concentration, catalyst in other concentration, solvent, karepan, அது எவ்வளோ எடுக்கிறோம் லோயர் கான்சன்ட்ரேஷன் சால்வெண்ட் அமௌண்ட் 1 ml 2 ml சொல்ல என்ன ரியாக்ஷனு அதுவே 20 ml என்ன ரியாக்ஷன் வருது. ஸோ டைல்யூஷன் போக போக இந்த மாதிரி மேக்ரோ மாலிகுல், தீஸ் ஆர் ஆல் கால்டு மேக்ரோ மாலிகுல், தட் பிக் மாலிகுல்ஸ், ரைட்? தீஸ் மேக்ரோ மாலிகுல்ஸ் கேன் பி ஃபார்ம்டு ரைட் இன் த டைல்யூஷன்ஸ், மோர் டைல்யூஷன்ஸ். 1 கிராம் எடுத்துக்கிட்டு 2 லிட்டர் 3 லிட்டர் சால்வெண்ட் போட்டு நாங்கள் பண்ணுவோம் லேபில் அப்போ olden days, macromolecules, the cyclophanes synthesis. So we have tried all the possibilities with this small scale. See, do you know what is the scale we have done in the laboratory? 20 milligram scales only, 30 milligram scale only, because we don't have money to purchase that catalyst. 100 milligram only we are having. So that much small amount of that compound, you can see that if you ஒரு தும்மல் போட்டினா பறந்து போயிடும், ரைட்டா? அந்த மாலிகுல் நாங்கள் ஹேண்டில் பண்ணி இவ்வளோ வேலை பண்ணியிருக்கோம் சார், ரைட்? ஸோ ஐ எம் ஹேவிங் தட் எக்ஸ்பீரியன்ஸ். இந்த ஸ்மால் அமௌண்ட்லேருந்து 1 கிராம் போவேன், 2 கிராம் போவேன், 100 கிராம், 1 கேஜி, 1000 கேஜி வரை நான் இண்டஸ்ட்ரியில் ஒர்க் பண்ணியிருக்கேன். ஸோ பெஞ்ச் ஸ்கேல்லேருந்து ஸ்மால் ஸ்கேல்லேருந்து இண்டஸ்ட்ரியில் மேலே போகிறதுக்கு யூ ரெக்வயர் லாட் ஆஃப் பேஷன்ஸ், யூ ஷுட் ஹேவ் தட் ஸ்கில் செட், ரைட்? அது வந்து எக்ஸ்பீரியன்ஸில் தான் வரும். நானும் உங்களை மாதிரி கவர்மெண்ட் ஆர்ட்ஸ் காலேஜில் தான், சாதாரண காலேஜில் படித்தேன். எனக்கு ஃபீஸே வந்து நான் கட்டலை, எனக்கு ஃப்ரீயாக விட்டாங்க. தமிழ் மீடியத்தில் ஒரு வருஷம் நான் நாங்கள் ரெஜிஸ்டர் பண்ணேன். அதுக்கு தமிழ் மீடியத்துக்கு ஒரு 100 ரூபா தருவாங்க அப்போ படிக்கிறதுக்கு. அந்த இதில் நான் தப்பிச்சிட்டேன். அதுக்கப்புறம் இங்கிலீஷ் மீடியம் மாறிக்கிட்டேன். எதுக்கு சொல்கிறேன்னா, எங்கெல்லாம் வந்து நானும் உங்களை மாதிரி கஷ்டப்பட்டு தான் வந்தேன். ஆனால் எங்கள் அப்பா வாத்தியார், நல்ல டீச்சர், எனக்கு எந்த கஷ்டமும் கொடுக்கல மணி வயசு. அட் த சேம் டைம் ஐ நோ த சேலஞ்சஸ். எப்படி நீங்கள் எல்லோரும் கஷ்டப்பட்டு வந்திருக்கீங்க இந்த ஏரியாவில் படிக்க வரதுக்கு. நீங்களாம் வந்ததுக்கே ஐ மஸ்ட் சே தேங்க்ஸ் டு யூ, ஆல் ஆஃப் யூ. ஏன்னா இந்த மாதிரி ஜென்ரேஷன் வந்து கெமிஸ்ட்ரி இவ்வளோ பேர் பார்க்குறது ஆச்சரியம், ரைட்? I can congratulate that teachers also. Okay, go back. Time is running now. I'm going to complete within, as I told you, within 10 minutes. So once we have this molecule, again I told you what is the application. Any synthetic transformation, can you able to do that? Yes, we have done that using biphenyl boronic acid. This is called the Suzuki reaction. The boronic acid, carbon-carbon bond formation, you may name reaction, MSc lam padichirupinga, Suzuki reaction, right? So we have done that. We have made this compound. See that 1, 2, 3 phenyl rings are there. Conjugation is there. Obviously, definitely they might show some fluorescence also. It may be used as a biomarker also. We can see that. So that is the application. You have to think, right? And also, we can substitute with the various groups. So here we have used iodine in can, right? This double bond is a substitute with iodine and a methoxy or ethoxy corresponding group. The final session of my talk. So ring closing metathesis, I told. The two terminal alkenes are there. This ring closing enine metathesis. Ene, one alkene is there and one alkyne is there. So how do you cyclize it? So I'm going to rush here because due to the time constraint, maybe I may take another 5-10 minutes. Okay, because the surprise slides are there. I need to discuss a couple of. And then, okay, right, okay. So, thank you. Ring closing enine metathesis. Before starting any work, some literature work we used to do. So there are a few literatures are there to cyclize this. This is the ene group, alkene, and then alkyne. You cyclize it, you can get that furan ring, right? Dihydrofuran, right? Dihydropyrrole, right? Whatever that, how to do that. So we have taken that starting material, right? So this is our primary starting material. This is prepared by that alpha amino acetophenone with the indinone, with the condensation, simple condensation reaction. Within 2 minutes, you can get the product, right? Once we have that carbonyl group, that you can do a propagylation with any phenylacetylenes. You can get that that whatever the propagylated compound. This OH is again alkylated with our famous allyl bromide. See, I want to tell you that allyl bromide is very cheap. That's why we are working. If we have more money, we can go for some other also. We have that, we purchased also, but at the same time, we are very comfortable with that chemical. So when you are comfortable with the chemical, explore it as much as possible. That will be easy for you. So once we have this alkene and alkyne, the ring closing enine metathesis, we have entered with this compound. Again, we have prepared various starting materials. All are characterized. Whatever the previous mechanism, only what I told you. So these many compounds we have synthesized, right? And then finally the ring closing enine metathesis, again Grubbs catalyst, second generation catalyst we have taken, and then we have optimized the condition, right? Grubbs 2 catalyst was taken, 10 mole percentage, and the solvent is dichloromethane, right? Refluxing condition, 5 hours, end up with it 69% isolated yield. The once you have the molecule, you have to characterize the molecule by all the spectroscopy technique again. So these are the various molecules we have synthesized, and then finally we got that X-ray diffraction study. So this work is published in a tetrahedron more recently. It's a good reputed organic journal, right? So again, the second work is a similar type of work. We have taken that starting material, isatine, right? Same type of conversion we have done. So we have made all the compound like this, right? Once the ene and iron are ready, right? We have all the starting material. We try to cyclase it. What are you saying? Ring closing metathesis. And so we have got that corresponding molecule. These are the various molecules we have synthesized in our lab. One student have done within 6 months these many compounds. He has completed his PhD, right? Mr. Kevin, sorry, Dr. Kevin. Now he is a doctorate. So why I am saying that, just put up hard work, everything is okay, fine. Right? Chemistry is like that only. It may not leave you without doing any hard work. Reaction is not coming, work is not going, it won't respect. Okay, so this work, again, more recently, one of my students have done that, right? So a girl is done it, she has completed, she is going to communicate this work in a good reputed journal. She has got that every step, right? One crystal, she has got here one crystal, and then she has prepared that corresponding ene, right? The same methodology we have followed, and then we have made that corresponding starting material for before the graph cyclization, and then we have optimized the conditions. Finally, she has done that. The Graphs 2 catalyst, 20 mole percentage solvent, toluene is the solvent at 90 degrees centigrade over 1 day, 24 hours. So you can end up with the 70% yield of this compound. Again, the structure of the product is confirmed by single crystal XRD. So what is the mechanism, how this is happening? With this slide, I'm going to conclude, right? So what initially that this is the starting material for the graph cyclization. Here ruthenium is coordinating. That is a 2+2 addition. It can form the cyclic ruthenium ring. All right. Then it is a cycloreversion. The ring is opening here, and the ethylene, one molecule of ethylene is going out in this ring closing methodology, right? And then that is ready. That C double bond ruthenium is ready. That can coordinate with again with the alkyne, and then again the 4-member ring is formed. Cycloreversion is happening, right? So you may get that corresponding product. So this is the methodology. It's a mechanism. Whenever any reaction, you have to propose the mechanism, right? Also, you have to do supporting experiments to confirm the compound is formed or not. So the summary slide. So this is the first part of the work. Dr. Novanna, he was my student. Now he is working in Chem-Biotech, TCG Life Science, Calcutta, as a manager, R&D manager. If anybody require any help, you can approach me also, no problem, regarding job. So, 9-member ring diazininone, this is also confirmed by XRD. All the azepines, pyrols, bipyrols, pyridines, dihydropyridines, all synthesized and summarized here. Both the works are published in good journals. And then this is the work done by my PhD student. So she has published this work in Chemistry Select more recently. In ring closing ene metathesis, so we have prepared various oxindole, quinoline, quinaxaline derivatives of all type of cyclized molecules using Graphs catalyst, ring closing ene methodology. So one part of the work is published in tetrahedron more recently. The other part we are going to submit. Manuscript is under preparation. So this is the place where I came from. I'm coming from, right? So I'm working here last 13 years. Before I was working in industry, I told you 7 years. I was in industry after my PhD, my postdoctoral period, right? So I came from moderate family only. My father allowed me to grow, right? I learned everywhere I learned. And then I've been in the industry. So still today I have some contacts with the industry, right? So that chemistry is different, that part is different industry. You can earn more money, but satisfaction in the academic only you can get it. While teaching, for example, teachers also, I'm saying that you are seeing the students again and again, you will get motivated because I want to leave my job, I want to resign my job, I thought, but my students are not allowing because I'm seeing again and again, I'm seeing new faces. These students, one batch, I'm going to send them out. Next batch, if I have that, then I will sit again. See, the only students only holding us, right? Understand? So this is the excellent job, academic job. What I feel that teaching job is very noble, professionals. So that's what I want to say here. Here at VIT, actually we are having very big chemistry department. More than 77 faculty members are there in chemistry itself, various domain. Pharma, nanotechnology, photophysical studies, sensing studies, physical chemistry especially, analytical chemistry, organic chemistry, right? I am doing in organic chemistry, I am doing basic research, but each professor will be allowed only 6 students for PhD. So we are having big research group, around 385 students are there, PhD students, right? 385 students. Every year, 2 times they are recruiting the PhD students. So that many PhD students are also going out. Understand? The vacancies are filled by every year 2 times. One is in the month of January, the other one is the month of June. The advertisement came already. I'll show you the next slide. So what is that next? Let us see. So I'm not promoting PhD here. By the way, I'm not promoting VIT. I'm saying that you should know that there are a lot of opportunities. You may not hide yourself within the cage. Cage means within that Madurai, right? Understand? You have to come out of that, right? Then only a lot of opportunities. Not only VIT, many colleges, many institutions, they are opening up. But in that, VIT is a pioneer. They are providing you a scholarship. See, if you want to go to PhD, what do you think? CSIR, I need to qualify. GATE, I need to qualify. Yes or not? Right? But it is not required. You just qualify VIT entrance exam. You have to apply. There will be an entrance exam, multiple choice questions, right? So luckily you are selected. You will be asked to come and attend the interview, right? Interview, there is a panel, and the same day or next day they may conduct. Once you are passed, right, around, for example, 200 students are attending, at least 50 students will be taken. See, the chance is also more that 50 students will be provided a stipend of how much? How much? If you go to the job, how much salary you can get it? Less than that also, right? So for that, for 3 years they are giving this. For 3 years. Within that 3 years, you have to save money, and then rest of the 1 year, 2 year, you have to manage, or you have to get that SRF, Senior Research Fellowship, in the CSIR and other funding agencies. It's very difficult to get that, right? In organic chemistry, minimum you need to spend 4 to 5 years. The other part of chemistry, maybe if you are doing well, working well, publishing the good papers, you will be asked to leave also. Even organic chemistry, minimum 5 to 6 years also, right? So I have worked 5.5 years to get my PhD. One of my students worked 6.5 years. The other student, I'm not seeing him. He's disappeared sometime. After some time, I'm seeing now he is going to complete. More than that, it all depends upon your situation, scenario, financial condition, family conditions. Many things are there. But same guide only, I'm going to send my students very early also. Those who are completing. My requirement is you have to complete this work, complete your PhD, enough, get out. I want to see next generation. So 4 years also, it is possible, 4 years. So 3 years a fellowship is there here, right? Understand? So you can manage within 4 years if you work hard. Luckily you are getting the results, luckily you are getting the publications, your life is good. Otherwise 5 years, you can extend, right? So that will be over. But 3 years you are earning. You can save money also, 35,000, right? You can give 10,000 to your parents. Rest of the money you can keep it for you also. Also fees, how much fees you are, see these colleges are providing that fees, part of the fees money to you also. 40,000 you are paying fees per year means 10,000 they will ask you to purchase the chemical. Facility, most of the analytical facility, what is there in the world, everything is there in our institution. It's a private institution. So not only my institution, other institutions also, IIT, if you go to CLR, CSIR institution, most of the institutions, they have NMR. Even MKU also there, Madurai Kamaraj University, they are doing excellent work, right? So the government institutions, they are having all the analytical facilities. If you want to use our facility also, it is available. You can pay some money, you get that analysis. So now world is very wide open. How are you going to take up? That's very important, right? So you have to take a call. Whether I want to stop at the MSc and go and get married and settle in a family sector, fine, that's your wish. Right? No, sir, I want to study higher. Okay, you can go. So I want to go to industry, excellent, welcome. But the world is very big. Competition is also very big. You should understand that, right? So I must thank our beloved, respectable Chancellor, Dr. G. Vishwanathan. He is the alumni of Loyola College. I was saying to your father, right? He's alumni of Loyola College. So he is the visionary. So he brought that. See, Vellore is a very remote area. From there, he has made such a wonderful facility. So he is giving a lot of support to all the faculty members. That's why it's my wish. The first I need to acknowledge is my senior, Dr. P. Shanmugam, Chief Scientist, CSIR, CLRI, Chennai. He is in Madurai also right now. He is giving lecture in Madurai Kamaraj University right now. So without him, he is senior. I want to say that. Senior means when I was doing my MSc, he was my PhD senior actually at the time. So he taught me everything. How to do that, how to do the column chromatography, how to do that, like that. My only seniors have taken care of us. Without them, we are not here, right? So the moral support, also my students, I can exchange my students to his lab. They can visit his lab and use the facility. That is possible. You can go to, suppose you are doing PhD, you can go to another lab also, explore the things, what is wrong. No one will kill you, right? So use the opportunities. All are there in front of you. Whether you want to eat or not, that you have to decide. Yes or not? Lunchtime. That's why I'm saying about eating, right? So this is my small group. The center is in me only, right? She is Pavitra. She is Preeti. All are here. Batma Shija, the ring closing metathesis work she has done. So other students are also unhappy because I'm not showing their work. But time is not there. So one of my MSc students, Ankita, is there. Sanjay is there, very right, my boy. So he is Mr. Dr. Kevin, and then Devendra Reddy. He is working in industry as a manager right now. So Sanjay is there here. See that, the last man. So I wish to thank the organizer, especially Dr. Savita Devi Madam, because she asked me, sir, you have to give a lecture about, because we are going to conduct a conference. At the time, without any hesitation, I accepted. So I must thank the organizers and then the officials, the college management. My sincere thanks to them. Please pass my thanks to them, madam. Also, I must thank all of you for your wonderful listening. I cannot see, maybe one or two have diverted, right? So maybe you are attracted by my speech or the opportunities, what I told the last two slides I told, because no other way. So you have to come out, you have to come away. Then only, at least one or two students, they are taking PhD from this group. I am happiest person in the world, right? Or 3 or 4 students goes to a work industry, very, very happy, because industry is very challenging nowadays. They are providing a lot of salary. You know that my student is Devendra Reddy. He is the manager of Anthem Bioscience in Bangalore. So he is earning more than me what I am getting, I'll tell you, salary. Right? So don't ask me what is the salary. Right? So why I am saying the industry, they are paying very high. But you have to work hard. He has worked in the industry more than 15 years. Right? After 15 years only that kind of growth. But if you have a PhD and entering into the industry, very short, very, very fast you can go and climb that place. Understand? So, good luck, study well, perform well. Welcome to our university and other research institutions. Thank you very much.
Now the forum is open for discussion. Any questions, clarifications?
If you have any doubt, please ask me. Otherwise, my contact details are there with the madam. Please contact me.
Okay, in the absence of questions, I thank Professor Kannadasan for an excellent piece of work, shared excellent piece of work, and it was really very interesting the way he told the stud வந்து click பண்ணோன்னா it is like அப்படின்னு சொன்னது. It was really very amazing because ஒரு கான்செப்ட் புரிஞ்சுக்கணும்னா we have to start from the very simple thing. ஸோ தெரிஞ்ச விஷயத்துலேருந்து தெரியாத விஷயத்தை போகிறது தான் பெட்டராக இருக்கும். ஸோ இட் வாஸ் so nice. Thank you so much, and thank you very much for accepting my invitation because it was very short notice. I asked you and immediately you said yes. Thank you so much, sir. Thank you.
I think it's the time for the presentation of our students, our PG students. So may I request Professor Martin to take up the session. So we all be here patiently listening to what our students are saying. May I request Professor Martin to take up the session.
குட் ஆஃப்டர்நூன் சார். அங்கேயே கத்துறான் சார், பசிக்குது சார் அப்படின்னு. அறிவு பசிவு இருக்கணும், சரியா? நம்ம இன்னும் கொஞ்ச நேரத்தில் ஒரு 2 ப்ரெசன்டேஷன் முடிச்சுட்டு வில் கோ ஃபார் லஞ்ச், ரைட்டா? ஸோ த ப்ரெசன்டர்ஸ், ஓரல் ப்ரெசன்டர்ஸ், யூ வில் பி given 5 minutes ஃபார் யுவர் ப்ரெசன்டேஷன் and 4 minutes for presentation, 1 minute for your clarification. All right, shall we start? Okay, we'll invite the first speaker, Kogula Krishnan. என்ன சொல்ல விரும்புகிறேன்னா, உங்களுக்கு thirst சொன்னார். காலையில் thirst சொன்னார். ஸ்டூடெண்ட்ஸுக்கும் thirst இல்லை, வாத்தியாருக்கும் thirst இல்லை, ஃபெசிலிட்டிஸ் இல்லை இந்தியாவில். இதுதான் பிரச்சனை. 1928 நோபல் பிரைஸ் வாங்கினாங்க, இன்னும் யாரும் வாங்கலை இந்தியாவில் இருந்து. இட்ஸ் ரெடி? ரைட், ஓவர் டு யூ.
Good afternoon, Anandar present here. Today I am going to present about our project titled as Synthesis and Structural Characterization of Nickel Oxide Graphitic Carbonated Nanocomposite via Salvothermal Method. Myself, Mr. M. Kogalakrishnan, doing MSc in Arul College, under the guidance of Dr. M. Amal Raj, Assistant Professor, PG Department of Chemistry, Arul College. Today, before going to the topic, we all know what is nanocomposite and metal oxides. Metal oxides is one of the major part and lots of attention nowadays using as a catalyst and electrocatalytic and lots of advantages and applications. Among metal oxides, nickel oxide is the important transition metal oxide with wide band gap from 3.6 electron volt to 4 electron. We are all known about band gap. Band gap is nothing but the energy gap between the conduction and valence band. The controllable size and surface volume and morphological properties of nickel oxide nanoparticles have promoted their usage as catalyst kind of things. In the study, preparation of sample via solvothermal method, which is simple and will compound with high yield and purity. Nanocomposite, two compounds are exist there. One is nickel oxide and another one is graphitic carbonate. Graphitic carbonate is nothing but the urea, some kind of nitrogen connected compounds. Urea, melamine are decomposed at high temperature. It will give graphitic carbonate. Carbonate is a compound consisting only of carbon and nitrogen atoms. Carbonate is also known as the organic semiconductor with band gap of 2.7 electron volt. It is like a polymer structure. This is a SEM image of the graphitic carbonate. It is like a layer structure. From SEM, we can analyze the structural morphology of our compound. Aim and scope. In this aspect, preparation of nickel oxide and graphitic carbonate was carried out of their structural characterization study. Previously, preparation of composite of nickel oxide and graphitic carbonate were reported the literature with follows a two-step mechanism. That is, preparation of nickel oxide and graphitic carbonate. They were prepared separately, and then they compounding them using solvothermal procedure. In our work, both are achieved in one single step synthesis method. That is same solvothermal method. Characterization of composites by FTR spectroscopy, XRD, SEM and DDAX. FTR is nothing but what are the stretching frequencies, metal oxide bonds and C double bond, C bonds. The stretching frequencies that to be analyzed. XRD is nothing but the crystalline nature of our compound to be analyzed. SEM is the already I said that is the morphological study. EDAX is the what are the composition present in our compounds in like elements composition present in our compounds. These are the experimental section. I took nickel chloride hexaoctane for nickel and melamine used as a combustion via melamine or urea, I already told. Synthesis method is a solvothermal method. This is the schematic representative of our synthesis method. First, nickel chloride hexaoctane, urea take 1:10 ratio. If 1 gram of nickel chloride is taken, the 10 times increase the urea is taken. 70 ml dissolved in 70 ml water, stirring 30 minutes. After stirrer, we go to the solvothermal method. nickel hydroxide only. These are the FTR characterization of FTR of our compound. This first one pic shows the C double bond O present in our compound, and the second pic shows the metal oxide bond present in our compound, and third one shows the graphitic carbonated. Nothing but the CN bond, stretching bond is present in our compound, and fourth also gives the C single bond and stretching frequency, and the fifth one is knows the OH or NH bond present in our compound. I only mentioned what are the stretching frequencies are present in our compound. The other peaks are like C double bond O, C gas peaks also exist and impurities on our compound. So I only mentioned what are the stretching frequency exists in our compound only. Future is study. When annealed at 300 degrees Celsius, formation of metal hydride was observed rather than the metal oxide bond. Hence, the annealing temperature was increased to 400 degrees and 5 degrees Celsius to prepare the metal oxide. XRD spectrum of samples annealed at 400 degrees and 500 degrees Celsius will be taken to confirm the formation of metal oxide and graphitic carbonated nanocomposite. After and also we would like to analyze after increasing the temperature, we'll study whether the graphitic carbonated bond is broken or not. Further characterization of the SEM and EDAX analysis will also be carried. Because what are the structural composition, morphological of our compound, and what are the elements present in our compound? Thank you. I would like to acknowledge my guide, Dr. M. Amarraj, who always motivates us, and I would like to acknowledge the Department of Chemistry, Arul, Anandar College, conducting this EFC 2024 and making opportunity to present my topic. Thank you.
Very nice presentation. The next presenters, the room is shifted. Okay, I will go to AV hall. Okay, all the presenter, you go to AV hall and present. Anita, you start with our AV hall.